Hello and welcome to Friday STEAM with the Warren County Library System. My name is Sandy Roberts and I am the Makerspace Coordinator for the library. And each week I bring you Friday STEAM at 3 p.m. Friday STEAM is all about science, technology, engineering, art, and math combining as we learn something new. So each week we'll have a little science lesson and then a fun experiment that you can do at home. For the next couple of weeks, we're going to be studying states of matter. So a little bit of atomic theory, we'll be doing some chemistry, and just generally learning about liquids and solids and gases, and then all kinds of fun things like non-Newtonian fluids like plasma and such. So we've got a really fun couple of weeks planned, and I'm really excited to get to explore these topics with all of you. We are going to start with solids, okay, because that's a good place to start. So I have some great interesting information to share with you, and then we are going to make sorbet. We're going to play with one of those transitions from liquid to solid. So the supplies that you need for today are fairly simple. You will need 2 bags. You're going to need like a quart size or a sandwich size bag with a good sturdy zipper top, and you're going to need a gallon size bag. Again, with a zipper top. If you have freezer bags, that's even better. I have the regular kind, but if you have the freezer bags, those are even better. You will need some fruit. So I have, they're warming up here, I have some strawberries. Now, I love to use frozen fruit for this. And the reason for that is that freezing the fruit breaks the cell walls, for those of you that are biology buffs, and helps to break down the fruit, so it's even easier to make into sorbet. You can also add a bit of honey or sugar if you like. It's really up to you. And a bit of lemon juice is also really nice to add to your sorbet. But I'm going to go with straight up strawberries today because I'm avoiding sugar after all the sugar of Halloween. You will also need something like this. Kosher salt, table salt. I actually grabbed the ice cream salt that you can get at the store for this project because you want the bigger the grain, the better. So you can see, I think you can see, yep, there you go. Some nice big grained salt. And of course you're going to need ice, which I have in a couple thermoses back there, and I'm not going to take it out yet because I want it nice and cold. I don't want it to melt on me. So that's all you really need to do. All you really need for this project. So if you don't have it, now might be a time to send mom or dad to run and grab. Just a quick note, I am following along on my phone, so if you have any questions, I am happy to answer them to the best of my ability. Whoop, if I don't drop my phone. Okay, why don't we get started learning a little bit about what makes up matter. So we are going to switch. Okay, there we go. Oh my goodness, it's on the wrong slide, Sandy. Let's fix that, my friends. It started at the end instead of the beginning. Okay, so today we're going to talk about solids. But for starters, we have to talk about what makes up all the stuff that we have in the world. And for that, we need to talk about atoms and molecules. So atoms are your building blocks of all matter. You can think of them as like little Legos that build everything else. They are defined as the smallest units of matter that have properties of an individual element. So though atoms are made up of even smaller things, as you can see in my picture with our protons, neutrons, and electrons, those are kind of like, well, they're standard bricks, you know? But once you build something from those bricks, now you've got an atom. And each atom's going to be a little different, okay? And they have different properties. For example, oxygen is an element, and it's very, very different than, say, neon, right? They're both gases, but oxygen we need to breathe. It's flammable. Neon is not flammable, and we can use it to make beautiful lights. So very different properties. Each element, different elements have different atoms, and so the structure of the atom is different for each element, okay? And atoms, of course, as I mentioned, are made up of even smaller things. We are today most interested in those electrons, which are super tiny and move really, really fast in clouds outside of this nucleus, okay? Those clouds are really important because they're kind of like layers, almost like cake. And some of those outer layers aren't full. They have extra seats available. They have extra spots in that outermost cloud. And that's how we get to the next thing. There are about 120 elements, and if you get a periodic table, you can learn some of the different elements, and that's a really fun thing to do. Now, when atoms come together, when we combine them, as you can see in my picture, we have our oxygen atom in the center and 2 hydrogen atoms that have bonded to the oxygen atom. And you can see those electrons, again, we had an empty outer layer, or a layer that wasn't full. And one thing about atoms, they want that outer layer to be full. You can kind of think of it as you wouldn't want to have a raincoat with holes in it, right? Well, an atom wants that outer layer to be full. So it's going to bond with other elements so that they can each have nice full outer clouds of electrons. And when they do that, that's when we get molecules, okay? And molecules are basically just atoms put together. Sometimes they can make a covalent bond where they're just borrowing the electrons, and sometimes they make an ionic bond where the electrons actually travel around both of those atoms in these crazy, wild patterns. So it's really about, covalent bond is when they travel around both atoms. Ionic bond is when one steals the electron from the other. But then what happens is they kind of turn into mini magnets and they stick together because one becomes positive and one becomes negative, and then they are attracted to each other. I'm not going to go into all the details about this, but I wanted to give you a little primer in case you haven't heard of this before. Because when we talk about solids, liquids, gases, we kind of have to talk about the particles that make them up, the atoms and molecules that make up these solids. So we call molecules, when small molecules build together and make macromolecules, we call these compounds. Okay, a compound is just a molecule made from different elements. Sometimes elements adhere to each other, like hydrogen does. But sometimes they just adhere to or bond with other elements. And when they do that, we call it a compound, a special name for that. There are millions of different compounds. So when people talk about chemicals, that's usually what they're talking about, is some kind of a compound. New compounds have totally different traits than the elements they're made from. Okay, for example, sodium is an element. It's kind of a shiny metal, a very soft, shiny metal. And it's extremely reactive. If you put it in water, it will explode. Yeah. Meanwhile, chlorine is a gas, okay, and it's poisonous. So you have a reactive, exploding metal, flammable metal, with a poisonous gas, sodium and chloride. And when you put them together, you get a molecule called sodium chloride. And guess what? It's salt. Remember, we were talking about the table salt before? So you have explosive metal, poisonous gas, put them together, delicious thing for your potato chips. Isn't that wild? Yeah. So the properties of the elements can be changed a lot when they become compounds. And this is a really important part of chemistry. Okay. So now we know about atoms and molecules. And again, that was a super quick introduction. Okay, and I'm going to give you resources to learn more. But these come together and they give us what we call matter. So in the universe, there's basically matter and energy. Okay? Energy, we can talk about another time. But today we're talking about matter, which is the actual stuff, all the stuff around you. Your matter. This camera that I'm talking into is matter. The air I'm breathing is matter. Okay? All of those things are matter. And they're all made up of atoms and compounds and elements and molecules. And they build together to create matter. Now, matter is officially defined as anything that takes up mass and takes up space. So anything with mass that takes up space, volume, is matter. What are mass and volume? I thought you might ask that question. So mass is basically the amount of matter you put into an object, okay? So you might have a very small object with a lot of mass, like a lead weight, okay, that you might use for fishing. Or you might have a really large object with very little mass, like a balloon filled with helium, okay? Very different scenarios there. But it really comes down to how many of those atoms and molecules are packed in there, okay? How many atoms and molecules do you actually have? So there is a difference between mass, which is directly related to the number of atoms and molecules in something, and the weight. Weight is actually a force, and it really has to do with how gravity on our planet is pulling that mass down. So the mass of an object is always going to be the same wherever it is in the universe, but its weight will change because gravity is different depending on where you are in the universe. So just a little side note to pay attention to that. Sometimes people use those two terms, mass and weight, kind of interchangeably, but they really aren't. I mean, and it doesn't really end up being a big deal because you're not likely traveling off to Mars today. So really it's okay, but just be aware that they are in fact different things. Anyway, so mass is the first thing that all matter has. And some matter has a lot of mass, some matter has very little mass. Then there's volume, and that's basically how much space you take up. I take up a sandy-sized piece of space, right? If you've ever gotten into a bathtub that was really full all the way up to the top, or had a cup of iced tea or a cup of soda that was filled right up to the top and then tried to plunk in extra ice cubes, you have seen what we call displacement. And that is the liquid gets pushed out of the way or displaced by the solid object, the ice cube, or in the case of the bathtub, you. When that happens, okay, you can see volume. You can get a sense of how much volume something takes up. So, an example, words such as big, little, long, short can all be used to describe volumes. Some things have very large volumes. I, for example, have a larger volume than my daughters do, right? And you know, a greyhound has more volume than a dachshund, for those of you that are into dogs. Different states of matter fill volumes in different ways, and this is important. Okay, this is one of the really important things about different states of matter. And we're going to be talking about solids today. So sometimes that can be actually, you have to take your volume measurements different ways depending on what state of matter your material is in, your matter is in. Okay. That was a lot of science. Moving on to the states of matter. So you probably are familiar with solids, like an ice cube, liquid, like a glass of water, and gas, like water vapor or fog. Okay? Those can be found all over the universe, and they're the most common states of matter that we find right here on Earth. But scientists recognize up to 5 different states of matter, including things like plasmas, Bose condensates, and things like that. So we will talk about those the last week of our states of matter presentation, but we mostly talk about gases, liquids, and solids. So we sometimes call those phases of matter because matter can be in any of those phases, can have any of those states. A physical state and the energy of the molecules basically determine what state of matter it's in. Okay, so solids have physical properties. They can be hard or brittle or shiny. Liquids are very fluid. They move around. They fill containers. So their volume changes based on what they're in. Well, no, their volume doesn't change. Their volume is the same, but that volume will take the shape of the container, whereas a solid won't. Gases, always around you. The molecules for gas are very far apart, and we're going to talk about that some. Gases can be an odor. You can sometimes smell like perfume. That can be a gas, those little particles traveling on the air. But gas is really spread out and very fluid and takes the space of whatever it is able to take. Now, we change from one state of matter to the next, okay? We call that a physical change because we're not changing the matter. Water is still water. It doesn't matter if it's an ice cube or fog, it's still water. Nothing about it has become unwater-like. So the molecules themselves move from one state to the next. And it really comes down to how much energy is in the system, usually in the form of heat. So you've probably experienced this. You leave your ice cream out to melt on a hot summer's day, right? That heat energy is working upon the frozen ice cream, and it is melting. It's changing state from a solid to a liquid. So there are other physical things, other physical changes that can occur. Pressure can make that physical change happen, either more quickly or less quickly. But mostly we talk about temperature when we talk about state changes. So that's how much heat energy is in our system. So when we have an actual phase change, right, it happens at very specific points. Very specific points. So we have the freezing point, which is when a liquid goes to a solid, or the melting point, when the solid goes to a liquid. And here's the thing. The freezing point and the melting point are at the same temperature. I know, right? Why do we call them different things? Because we're trying to say which state of matter we're going from and to. So freezing point and melting point are literally the same temperature, but a freezing point is going from liquid to solid, whereas a melting point is going from solid to liquid. Now, when we talk about liquid to gas, same kind of thing. When we go from our boiling point, okay, our boiling point is when our liquid goes to a gas, okay, and when it condenses, that's when our gas cools down enough and becomes a liquid, okay, and it all comes down to how much heat energy we have in that system. So when we talk about states of matter, you're going to hear a lot of freezing point, melting point, boiling point, condensation point. And if you've ever studied the rain cycle, you probably are familiar with those words. Since today we're studying solids, we're mostly going to be interested in freezing points and melting points. And we're going to use some really cool chemistry to play with those today. All right, solids themselves. Solids can be hard like a rock, soft like fur. They could be really big rocks like asteroids, tiny rocks like grains of salt. So they can take up many different shapes and forms, okay? For example, they can be a solid like me. The key to solids, though, is that they keep their shape. They don't flow like a liquid, okay? They don't take the shape of whatever they're in. They keep their shape. Solids can hold their shape because the molecules inside them are packed really tight together. Going back to my Lego analogy, if you have a big bin of Legos, just kind of all Lego pieces, you can pour that out. Those Legos will take the shape of your container that you're holding your Legos in. But once you build a castle with those Legos, right, it may not fit in your bin anymore because now it has its own rigid, hard shape. And it may not fit into that bin very easily. You're going to have to break all those Legos down again so that they are more fluid, okay? So solids are like very rigid structures. So let's take a look at that. Here's, that's not right. So solids, as you can see here by this picture, tend to have really packed in atoms and molecules. They're really tightly packed into usually a pretty regular shape. Okay, so those atoms and molecules are not moving around much. They're kind of vibrating a little bit, but that's it. When we get onto liquids and gases, those molecules are spread out more. They're moving around more. And that's why they're free to move and take over, whatever space they have. But solids can't do that. They're kind of stuck in a very specific arrangement. Sorry, I'm having some technical difficulties here. What are you doing? Mixtures, okay, solids can be mixed. So they can have different elements in there, different molecules in there, all mixed up into one solid. If you've ever looked at a piece of granite or a really cool rock and seen different veins or different colors or different compounds, you've seen this happen. Same thing if you've ever had ice cream with like candy in it, with like marshmallow in it and fudge and chocolate chips. That's a mixture. You can see all the different bits. Sometimes easier to see them than others. Another way to think of a mixture, a salad. You throw all your vegetables into the bowl, right? So you can have lots of different types of things in your mixture, in your solid. And the way we talk about this is that if you have a heterogeneous mixture, you have all of the molecules kind of uneven, just kind of floating around in there. And you might get like pockets of different types of material in your mixture. We see this a lot with things like concrete, okay? A homogeneous mixture we tend to see with liquids and gas because they're more easy and free to move. So you get your different compounds spread evenly through. So you can think of this a little bit like when you add a teaspoon of sugar to like a cup of tea. That sugar is going to melt and distribute throughout the tea so that each sip of tea is as sweet as the previous sip, right? If you took the actual tea from the tea bag and the sugar and stuck them in the cup, you're going to be able to see the separate layers, okay? So that's heterogeneous, which means different, versus homogeneous, which means same. Most of our solids are going to be heterogeneous if you're putting them together, like what we're making today will be fairly heterogeneous. It won't always be nice and evenly mixed. We're going to try to get as close to a homogeneous mix for our solid, and one of the ways that we can do that is by starting with something that's a liquid, because then you can get it all homogeneous, and then as you freeze it into a solid, now you have a nice mix of everything blended evenly. Okay, and last one, crystals. Crystals are a special form of solid, okay, and they are arranged so that every molecule is in a very specific order. We call this a matrix, okay, and these repeating patterns, these beautiful organized lattices, okay, form crystals like diamonds and all those kinds of things. And also, going back to it again, salt, okay, and sugar. These are all crystals, and inside every molecule is nice and neatly arranged. So crystals are kind of a very special substance. They usually tend to be fairly pure because if all the molecules aren't the same shape and size, it's very hard to form nice, neat blocks of everything. If you've ever built with Legos, you know exactly what I'm talking about. It is much easier to build a wall if you have all the same bricks to build that wall with, right? But if you've got to use lots of different pieces, it's going to be harder. Crystals are very strong because of this kind of the way that they're formed that way. So they tend to be really strong substances. So you can't do that with a liquid, and you can't do that with a gas. They don't have that nice rigid structure. So solids have some downsides and some upsides. And one of the upsides is that they're very strong. Okay, why is it doing that? I don't know what it's doing. All right, onward to the next slide. Now, if you want to learn more about this, because that was like a really quick, I just threw it all at you, kind of a science lesson there. Chem for Kids is a great website. They have really good explanations and good visuals. So that's totally free, and you can check that out. They have a whole section, lots of pages on states of matter. If you're more of a video kind of person, Crash Course Kids has a whole playlist on states of matter and on atoms and molecules. Really fun stuff. Very engaging, fun videos. So you can check those out. And last but not least, of course, our library has tons of books. Just go on to warrenlib.org and type in under the catalog, States of Matter, and you're going to find tons of resources. You can also go to our digital archives on Hoopla and find lots of cool books or ebooks about this type of science and states of matter. So I want you to go and check that out, okay? Go and learn lots more. All right, so that's our quick science lesson. Are we ready to start our science experiment? I know I am. All right, let's switch on back. All right, so I have all of my supplies now. My berries should be, they look pretty good. I'm gonna put them over here. I'm gonna get my salt, because salt is very special. And I've got my ice in a couple of thermoses. Okay, I hope that you have your supplies too. Let's switch on over to our camera, and here we go. Making sure the volume's up, yep. And I've still got my phone with me, so if you've got questions, I'm here. What we're gonna do today is we are gonna take our berries, we're gonna crush them up, and we're gonna basically make a liquid out of them, okay? But we wanna freeze that liquid to make sorbet. We are going to use one of the really cool properties of salt to do that, because we want to refreeze these berries. But that's really hard to do if I don't just stick it in a freezer. Salt has a special quality. It can lower the freezing temperature of water. And what that means is, remember how I said there's that kind of magical temperature that water is going to freeze at? By adding salt, it disrupts the water enough that you can make that water go lower than freezing temperature and still stay water. So we can mix ice and a little bit of water and a bunch of salt, and we can get our bag of this combination to get much colder than it would just by using ice alone. So it's a really cool thing. It is what we call it a suppression of the freezing temperature. you may experience this in the wintertime when your parents put down salt on icy driveways or sidewalks, because what happens is that it lowers the temperature that water in the ice needs to be at to freeze. So if it's 32 degrees out, it might lower that temperature to 25 degrees. And now it's not cold enough for that water to freeze. So it melts, okay? Great experiment to do. I'm going to tell you about it at the end as well, but let's get started on our sorbet so that we have time for that. We're just going to start by putting all of our fruit, about 2 cups of fruit, okay, into our smaller bag. And like I said, I like to use previously frozen fruit for this, but it's up to you. You can add a teaspoon or 2 of sugar to this if you like, or a little bit of honey. Like I said, I'm kind of skipping sugar right now. You could also use stevia. I do usually like to add a bit of lime juice or lemon juice, just a teaspoon in there. It adds a nice fresh flavor. You can also add herbs like mint or basil. Play with it. Make your own special sorbet recipe. Now I'm going to seal this up, and you notice I'm making sure all the air is out of there, right? All the air, which can take the shape of the container, but our strawberries cannot. Our strawberries are still going to be their strawberry shape. Well, we are going to fix that, actually. Come on, seal for me. All right. So what I'm going to do is, this is the fun part. You're smushing your strawberries. Get them smushed up. This is especially good if you've got any kind of sugar or lime juice in there, because that's going to help break it all down, mix it all up. So remember what I was saying about you want to get a homogeneous mixture before you freeze it, because it's harder to do once it's a solid. So we're going to basically make these all into pulp. We're going to get all the liquid that's inside our strawberries out into our bag and mix it all up. So you're going to take your time. You're going to really smush all these berries. If you want to, you can throw them in a blender and do it that way. It's up to you. I personally like to do the smush. I think it's fun. You don't want if your berries are room temperature, that's fine. I like to chill them a bit so that they're on the colder side when we get started, because that's just going to make sorbet making go even faster. Okay, so I'm pretty well smushed. You might want to take your time, make sure that it's all really, really smushed up there. Just be careful that we don't end up with an open bag. That's really important for the next part. So I'm going to make sure all my air's out, because air can actually be an insulator, and we don't want that. And make sure my bag is sealed up really well. Okay, we're in good shape there. Now, we're going to take our big bag, and we are going to add ice to our big bag. Here we go. You can use crushed ice if you prefer. I'm just using, my ice cubes have kind of melted together. I don't have a freezer nearby when I do this, so I kind of have to make it work. They're all kind of stuck in there. Oh dear. Maybe I shouldn't have used my coffee thermos, but I figured they'd keep everything pretty cold. I'm gonna get there we go. Got some ice now. Come on. This is challenging, sorry. They all kind of, what happened is my ice cubes started to melt and then they refroze together. So I'm having a little trouble getting them to come on out because they are stuck. Okay, that's kind of frustrating. Let's see if I can get this one. I got another ice cube. So you're going to want to add about, let me see, about 2 cups of ice. Okay? So I might not be able to get 2 cups of ice here. So you may have to bear with me here because they have all frozen together. I'm trying to break them apart. There we go. Now we're getting them. Slowly but surely. Persistence matters, right? Yeah. Sometimes you got to be persistent. Ooh, that is not a great sound. I don't know how that sounds to you. Oh my goodness. Come on. You can do it. Okay, well, I think we've got enough for you to get the idea. You're going to put 2 cups of ice in there. Crushed if you've got it. If not, whatever you've got is fine. We're just going to let that go. Okay, so imagine you've got a full 2 cups of ice in there. Now we are going to add 1 full cup of salt. And I'm just going to use my, since I don't want to dirty a second thing, and I happen to note this is about 2 cups. So I've got a cup of rock salt, and as you can see, it doesn't have to be perfect. You know, you don't have to worry about it being like a perfect measurement. And then we're going to add about a cup of water. I'm just going to grab my water from behind, and in that goes. Okay. So that's my kind of slurry, okay, for my sorbet making. I'm not going to get lucky, am I? Nope. No more are going to come on out. Thought I might. Come on. I want sorbet. It's not going to let me have sorbet today. Oh, well. Okay. Oh, there we go. Oh, we got one more. Okay. Now, you've got all that. Kind of mix it together. And you're going to take your other bag. You're going to put it in here. And we're going to seal up the larger bag. Again, making sure all the air is out. Okay. And this is the fun part. Then you start to shake. And it gets cold. You will feel it get colder and colder as you shake. So you're going to just shake and shake and shake and shake. Usually when I do this with my kids and at home, we will actually toss the bag back and forth. You might want to put it in another couple of extra bags for that to make sure that it doesn't end up breaking on you. But you're just going to do this, and it could take some time. Sometimes it could take up to like 10 minutes of kind of mixing it. And you're just going to keep on doing this until that sorbet comes together and refreezes. Okay? And that's how easy it is to make nice fresh fruit sorbet out of just simple things that you can find at the grocery store. Okay, coming back over here to our other camera. So that's a fun way that you can use freezing points, okay, to create something from a liquid to a solid, to take your fruit puree and make it into a nice cold sorbet. The other experiment that you might want to try is based on Mythbusters. Okay, if you've ever seen the show Mythbusters, I am a big fan. And they did test the myth of, can you cool your, well, they said beer, but can you cool your soda faster in a tub of ice and water, or a tub of ice, water, and salt? So I encourage you, get 3 bowls, ice into all the bowls, water into 2 of the bowls, salt into 1 bowl. And put identical cans of soda into all 3 and see which one gets coldest the fastest. It's a really fun experiment, and I encourage you to find that episode. I do believe you can get it. I don't want to say that we can get it through the library. I don't recall if we can get all of the Mythbusters episodes. But there are shots of it on YouTube from Discovery Channel. So if you go to the Discovery Channel website, they do have that as a clip. It's a really fun experiment to do, so I encourage you to try that one out too. All right, that's Friday STEAM for this week. I hope that you enjoyed. Next week we'll be talking about liquids, and I've got some more fun experiments for you to do. Again, my name is Sandy Roberts, and I am the Makerspace Coordinator for the Warren County Library System. Please take a look at our website, warrenlib.org, WARRENLIB. Let's see if, well, my website is not going to come up. I don't know why. But you can check out our event calendar there. We've got lots of great stuff coming up. In fact, tomorrow we have a performance of The Wizard of Oz. We've got Sherlock Holmes. We've got great music, story times, Pokemon, crafts, gaming, tons of great stuff. So make sure you check out that event calendar. We have a lot of programs for you online, even though we can't be together. Remember that our libraries are open 1 day a week from 9 a.m. to 8 p.m. So Monday is Northeast, Tuesday is Southwest, Wednesday is headquarters in Belvedere, and on Thursdays, Southwest is open. So you can get into the library and browse some books, use the facilities, use the computers. We love seeing you. Okay, I will see you next Friday for Friday STEAM, where we talk about liquids. Have a great weekend, everybody.